this is Ms. Bufford, and in this video, we're going to talk about families of the periodic table. So your learning goals here are to be able to identify where the alkali metals, alkali earth metals, halogens, noble gases, and transition metals are found on the periodic table, and to be able to list some properties of each of these families. And so here's a quick overview of where these families are located. We've got 4 families that are located within the main group of elements that we need to be familiar with. The first one is over here in group 1A or group 1 on the periodic table, and that is the alkali metals. And then the alkaline earth metals over here in group 2 or group 2A. And then over on the other side in group 7A or group 17, depending on which numbering system your periodic table is using, we have the halogens. And then in group 8A or group 18, we've got the noble gases. And then we're going to talk about the transition elements, which fill that D block right there in between the 2 main group elements. And then we are going to talk about the lanthanide and actinide series just a little bit, just because I always have students that are really curious about the properties of these 2 groups of elements down here at the bottom of the periodic table. So we're going to start here with group 1. This is the alkali metals. And chemical properties of these metals are that they are the most reactive family of metals. So because of this, they're not really found freely in nature. They have to be extracted from compounds that they're found in. So we're not going to go on a walk and find a nugget of sodium. It's just too reactive. It won't exist by itself in nature. These metals, everything in group 1, they tend to lose their 1 valence electron and form +1 cations when they're undergoing a chemical reaction. And so if we take a look over here, here's our group 1 elements. We've got lithium, sodium, potassium, rubidium, cesium, and francium. These all react very violently with water to form the metal hydroxides. Physical properties. They're all shiny, silvery, lustrous metals. They're malleable. They're very soft. They can be cut really easily with a butter knife. They have low densities, so lithium, sodium, and potassium can actually float on water while they're reacting with it. And they also have low melting and boiling points compared to most other metals on the periodic table. One thing that I did want to point out is you'll notice that hydrogen is not included in this family, and that's just because hydrogen is a non-metal. It's grouped with them because of its electron configuration, but it's actually not part of the alkali metal family. All right, the next group is group 2. These are the alkaline earth metals, and they are the second most reactive group of metals. Again, just like the alkali metals, these are not found freely in nature. Just because they're so reactive, we have to actually extract them from other chemical compounds that they're found in. These metals tend to lose their 2 valence electrons. So they're in group 2, they have 2 valence electrons, and they're metals, so they tend to lose those, and they form +2 cations in chemical reactions. These tend to react with water to form metal hydroxides as well, but beryllium is actually the only one that does not react with water like all the other elements in the group. Some physical properties are that they are shiny, silvery, and lustrous. They're malleable. They're somewhat soft. They're not quite as soft as the group 1 metals, but they're still kind of soft. They have low densities and low melting and boiling points as well. All right, so group 7 is the next group family that we're going to talk about, and this family is the halogens. And this is the most reactive family of non-metal elements on the periodic table. These elements tend to gain 1 electron when they're undergoing chemical reactions, and they form -1 ions. All right, so they are all trying to have 8 electrons in their valence shell, and so in order to do that, they're going to go ahead and try to gain 1 more electron. They tend to react with group 1 metals in a 1-to-1 ratio and group 2 metals in a 1-to-2 ratio to form ionic salts, and we'll learn more about this in our next unit on chemical bonding. But their physical properties, they all have a color to them, so they're all colored substances. Some of them are gases, like fluorine and chlorine at room temperature. They are a pale yellowish greenish gas. Bromine is a liquid at room temperature, and it's got a reddish brown color to it. And then iodine is a solid. So if you take a look at this purpley flask right here, there's some purple iodine gas in there, but iodine is also a solid at room temperature. It's like blackish purple in color. It's really pretty. They all have low melting and boiling points. When they're solid, they are brittle solids, and they are poor conductors of heat and electricity because they are nonmetals. And one other important thing about these elements is that they're all really toxic, but they're really useful. And some uses that we have for them, and this is just a very simple explanation or example. Fluorine, for example, we use fluoride ions in our toothpaste to keep our teeth nice and white and clean. Chlorine and bromine are both used in swimming pools to kill bacteria in swimming pools and keep that water nice and clear. And then iodine is used in the medical industry to prep patients for surgeries and to clean implements and stuff like that. All right, so the noble gases is group 8. In this family, we have a family of gases. They're all gases at room temperature. They're all colorless gases, and they tend to be what's called chemically inert, which means they are very unreactive. They're hardly ever found in compounds in nature, especially helium, neon, and argon. They're always found as single atoms all by themselves, and it's because they have that full outer shell of electrons. They don't really want to gain or lose any electrons, so they tend to not involve themselves in chemical reactions. There are some compounds that are known to exist that have krypton, xenon, and radon, the largest of these noble gases. And that's just because they've got valence electrons that are really far away from their nucleus. And so they're not under as much influence from their nucleus as the valence electrons around the smaller noble gases. And we'll talk more about that in our next video when we talk about the trends on the periodic table. But another piece of information about these is that the boiling points and densities will increase as we move down this group. All right, transition metals. So these are all of the metals that are sandwiched in between the main group elements on the upper body of the periodic table. So the D block is what we're talking about here. These can have variable valence because their valence electrons are located in multiple shells, so multiple different energy levels. And so it's really hard. That makes it difficult for us to predict how they will behave chemically unless we have experience and we know ahead of time how they're going to behave. So they have what's called variable valence, meaning that they can form ions with different charges. They often form colored ionic salts. So when a transition metal reacts with a non-metal, they form what's called an ionic salt. And these happen to be something that's really colorful. So we've got potassium dichromate. So chromium is in this compound. That's a transition metal. Then we've got iron sulfate, cobalt chloride, copper sulfate, and nickel sulfate. So you can see that these form some really pretty colored compounds. These metals are less reactive than the alkali and alkaline earth metals, and that's just partly because their valence electrons are located in more than one energy level, and so it's harder to get these to react. Some physical characteristics is that they actually vary in appearance, so we can have anything from a shiny silvery substance to something that's kind of dull grayish, and we can have colored metals like gold and copper in this group. They tend to be good conductors of heat and electricity. They are malleable so that we can hammer them and shape them without breaking them. And they're ductile so we can stretch them into wires. They have high melting points except for mercury, which is a liquid at room temperature. And they also have high densities, and they're usually very hard metals. All right, so now we're going to talk about the lanthanides and actinides, and you don't have to know a whole lot about these elements for this class, but I wanted to go ahead and give you guys some more information than I normally do because I always get questions from students about, the properties of these elements, and so I did a little bit of reading and I found out some more stuff, and I'm just going to share it with you guys. So this is part of, the lanthanides are the top row here in the inner transition elements, and these are elements 57 through 70. They have valence electrons in their f orbitals, except for these elements right here, which they have there's exceptions to their electron configurations because of stability issues. But all of the elements in the lanthanide series form stable +3 ions. Usually the +3 ion is formed. Sometimes they can form a +2 or a +4 ion, but stable +3 ions is what's usually seen. Several are very highly reactive, and all of them except for lanthanum are pyrophoric, which means they can burn in air at low temperatures. And so low temperatures here, we're talking about temperatures above 150 degrees Celsius. So it's still kind of hot, but these can burst into flames if you get the temperature too high. They're very reactive. They are usually silvery white in color. They have high melting and boiling points. The lanthanides are all non-radioactive except for promethium. So that's the only radioactive element in this series. They are soft enough to be cut with a knife. And many compounds containing lanthanides will fluoresce under UV light, and they're used to make phosphorescent or glowing materials. So you can take a look at, this is just a picture of showing that lanthanum is used to make fiber optic cables. So that's pretty interesting. All right, and the actinides are the bottom group, the bottom series of elements along the very bottom and the F block. And this is elements 89 through 102. And these elements all have variable valence, so they can form a variety of different ions with different charges. They are highly reactive with the halogens and other nonmetals. They are also pyrophoric, so they will burst into flames at elevated temperatures. They are silvery in color. All of these elements are radioactive. They're malleable and ductile, and then many of these compounds will also fluoresce under UV light. So this is an example of some antique uranium glass. And if you've ever been to an antique store and you've seen some of this under a black light, they're just displaying the fact that it's uranium glass. It's got actual uranium in it, and it's causing the glass to fluoresce under that black light. For this series, only uranium and thorium exist in meaningful amounts here on Earth. We have found plutonium, neptunium, actinium, and proactinium in very tiny amounts, and these exist in these small amounts as the result of radioactive decay processes. But all of the rest of the elements in this series are synthetically produced, which means we don't find them in nature. Humans create these in nuclear reactors. All right, so I hope this video was helpful. Let me know if you guys have any questions, and I will see you in class. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.